Everyone, in today's video we are discussing one more problem on pumping lemma theorem. So we have to prove the given language is not a regular. So what is our first step? So our first step is assume that language L is regular and here N is equals to pumping length. N is nothing but your pumping length. Okay. Next. So if what is prime number? So prime number is nothing but 2, 3, 5, 7, 11. Yes. So here we have to write first prime number n is equals to 2. So we get a raised to n is, we'll put a raised to 2, we'll get a square, and n is equal to 3, we'll get a cube, that is 3a, and n is equal to 5, we'll get a raised to power 5, we'll get 5 times of a. Yes, for all prime number we'll get. Yes. So we have to choose a string and pumping length. So we are choosing. So third step is we have to choose string W in such a way that W can be divided into 3 parts. It can be divided into 3 parts. So we can say W can be divided into X, Y, Z. So if we take a square, only 2 elements are there. We can't divide into X, Y, Z. So we'll take W is equal to a cube, that is we'll get a. Yes, here X, Y is one more a and Z is one more a, and hence we are taking this string. So our pumping length, will become, so pumping length n is equals to 3. So we have to check mod of W is greater than or equals to pumping length. So pumping length is 3. So when mod is, so it is a, which is nothing but 3 is greater than or equals to 3. Yes. Next we have to see how this string can be divided. So W is equals to a we have divided into X, Y and Z. So we have to prove that the first condition is, so we can say conditions. So mod of Y should be greater than 0, that is Y is equals to a we have given, we have not assigned below 0. Yes. Second condition, XY should be less than or equals to pumping length. So pumping length we have taken 3. XY, when we say a, that is 2 or lesser than or equals to 3, it is satisfying. So hence it satisfies. This is also satisfying. And next, third element, that is xy raised to power I into z belongs to language. So what this? So here a, for some I it won't be belonging. How we'll check? So for I is greater than or equals to 0. So for I is equal to 1, we'll start with 1. So a raised to power 1, a cube is belonging. Yes, it is belongs to language. Next, I is equal to 2, a square a. So what will get? 4 a's will get, which will not belongs to language, and I equals to 3, a cube a. So this is also belonging to language. If we see I is equal to 4, a raised to power 4 a will get total 6a, which is also not belonging to language. So we can say this condition, it is not satisfying for some I greater than or equals to 0. It doesn't belongs to, so string not belong to language, hence language is not regular.